Oh, yeah. Okay. All right, section 5. Solve quadratics by finding square roots. Let's go over some basic ideas first. We need to know how to simplify square roots. Now, here's what I'll tell you. This kind of parallels this. Would you ever write this as an answer on a test? 3/6.
No.
Some of you would, yes. Should you? No. What should you write? Good. People understand how to do the fractions here. 3/6 is 1/2, right? That's the same with this. If I ever see you writing square root of 80 on a test, it's wrong. Okay? I'll mark a point off for not simplifying. So the question is, how do you simplify a square root? So here's the method. There's a couple properties here. Here's one property. The square root of AB is equal to the square root of A times the square root of B. Here's property number 1. Now, so all this property says is if you have a product underneath the root, you can split them up. Okay? You don't see a product underneath here, but could you make 80 a product? What would you say?
8.
Most people would say 8 and 10. Okay? Let's do that. Let's do 8 and 10. So square root of 80 is equal to square root of 8 times square root of 10. All right? You follow the property? But is square root of 8 a nice answer?
No.
No? Square root of 10?
No.
No. So here's the deal. You have to break these down more. What is square root of 8? What can square root of 8 break down to?
4.
Square root of 4. Square root of 2. You're going to have to be real nice and neat on these because it's so easy to miss something. Square root of 4, square root of 2. Okay, that's nice. What about square root of 10? Square root of 5. Square root of 2. Now take a look at what will happen here. Square root of 4 is 2. I'm going to put it here. A whole 2. What about any of this? Can I simplify any of this? What about this? What are all these things doing? They're all being what? They're all being multiplied, aren't they? What's the square root of 2 times the square root of 2? Square root of 4, which is 2. I'm going backwards there. Square root of 2 times square root of 2 is the square root of 4, which is 2. I'm going to put 2 here. So is this 22 so far? No, it is 2 times 2. So we got 2 times 2 so far. What do we have left? Square root of 5. So I'm going to put square root of 5 on the end. Nice answer?
No.
Nope. 2 times 2, 4. 4 roots of 5. So if you were to simplify square root of 80, 4 roots of 5 is actually your answer. I need you to be able to do this because when you solve my equations now and you get square root of 80, you need to write 4 roots of 5 or whatever it is. All right, now, how do you know you're right? Because some people get this wrong. Let's try our calculator. Here's what I want you to do. Type in square root of 80 in your calculator. See what the decimal is. And then type in 4 times root 5. See what that answer is. And you notice it's exactly the same. That's like if I told you this. How do you know that 1/2 and 3/6 are the same? Well, divide. 1 divided by 2, 0.5. 3 divided by 6, 0.5. Right? That's how I know. Is it?
If you didn't have a calculator, could you double, like square the number in front and then multiply it by the number in the root?
Yeah, could do that.
Does it work every time?
Should. Yes. Yep. Now, is this a safe proof way to check your work? By typing in the calculator. Could you have an answer that is wrong that would give you the same decimal? How about that?
Yeah.
So this isn't like a foolproof way. Because what if you didn't fully simplify, right? Like this right here. What if I took this right here and said, okay, square root of 4 is 2, and then I just said, oh, those don't simplify. What would that become? Square root of 20. If you typed in 2 times square root of 20, do you think you'd get the same answer as this? Yes. Is that the best answer? No. You see how it's not a foolproof way to think your So here's a foolproof way. Just ask yourself this question. Whatever root you come down to, I got root 5. Say, can I simplify root 5 anymore? And the answer is no. So it should be the correct answer. Okay? But if you got square root at 95, you might ask yourself, is that the simplest form that would go? Check it. Right? Make sure you check it. Alright, that's how you do square root of 80. What if you have a product here? So square root of AB equals square root of A times square root of B. What could this be the same as? Square root of 6 times. Could I multiply these two and put them under here? Yeah, isn't that going backwards? Going from here to here. What is it, 126? I actually wouldn't even do this step because you're going to have to do what anyway right now? You're going to have to break down 126, right? But isn't 126 already broken down kind of right here? I wouldn't even do that step right there. Here's what I would do right away. I would say, okay, square root of 6 is? Square root of 3, square root of 2, square root of 21, square root of 3, square root of 7. And then just look at these right here and simplify. Square root of 3 times square root of 3. 3. Square root of 2, can I break it down? No. Square root of 7, can I break it down? No. So some people write square root of 2, square root of 7. Good answer?
No.
No. You don't want square root times a square root. You want to put them together, which makes 3 roots of 14. Final answer. There you go. Everybody with me so far? Basically, it's just breaking things down until you can't break them down anymore, writing the final answer. If you put this in your calculator and this in your calculator, you should get the same exact thing. Okay? Now, what if I got fractions? What if you got something like... Notice the book does something different. Look what they did. Square root of 9, square root of 14. Look at square root of 80, square root of 16, square root of 5. Their way is easier. What did they look for? Do you know what they look for? They look for perfect squares within 80. What's the perfect square within 80? 16. So life could be a lot easier if you think that way. Like if I gave you a number, if I gave you a big number, I don't know, whatever, 200. Look for a big square within 200. Okay? That would make life easier. Could you just say 20 and 10? Yeah, 20, break it down, 10, break it down. It doesn't actually matter. Just make sure your steps are perfect, okay? It doesn't matter what you break it down into as long as your steps are perfect. Okay, look at this question right here. Square root of 4 over 81. Here's another property, simple property. If you have square root of A divided by B, it's equal to square root of A divided by square root of B. All they did was split it up, okay? This question is real tough. Look. Square root of 4 divided by square root of 81 equals 2 divided by 9. You geniuses. Look at that. Look at that. Alright? So, if we have a square root of a fraction, just split it up into two things. Top, bottom, do them separately. Look at the last one. Letter D, square root of 7/16. Do that. Should take you about 0.5 seconds. Ready, go. Got it? Square root of 7 over square root of 16, which is really square root of 16, 7 over 4. Done. Good? You guys understand the properties going on here? Two properties. All right, let's make it harder. Let's give you test questions. Ready? Here's your first test question. You do. Here's one like I would give you. Actually, this was on last year's quiz. Here you go. Example. Square root of 90 times the square root of 8 times square root of 56. There you go. There's a quiz question for you. You're getting ahead of the game right now. Go ahead and do that. My advice to you, I would probably do one at a time. Simplify square root of 90, put it off to the side. Simplify square root of 8, put it off to the side. Simplify square root of 56, put it off to the side. And then multiply those together. Let me break it down how I would break it down. square root of 90. I would do this by itself. Square root of 9, square root of 10, square root of 9, 3. So if I just simplified square root of 90, I would get 3 roots of 10. I'd just put it off to the side. Square root of 8, you should know that one should be quick. What is that one? 2 root 2, because that's square root of 4, square root of 2. Square root of 56, 8 and 7. Or if you were thinking about squares within 56, what would be a square? What would be a square within 56? 4 and 14. But it doesn't matter. Square root of 4, square root of 14. So 4 is a square. That's nice, right? So you get 2 roots of 14. All right, now, this is this, this is this, this is this. You multiply these together. What are the only things you can multiply? The whole numbers, 3, 2, and 2, which make 12, 10. So you could do this. 10, 2, and 14 make 280. So really, your one step could be 12 square root of 280. But you should always ask yourself, could this simplify? And that's a big number, so probably yes, right? But if you type this in the calculator, do you think it would give you the same as this? This is why it's not foolproof, right? Make sure you simplify this. So I wouldn't even go here, to be honest with you. I would just do this. Square root of 10, square root of 5, square root of 2. I have a square root of 2 right here. And I have square root of 2, square root of 7. Look what I have now. Square root of 2, square root of 2 makes 2. I had the 12 out front. I got 2 from this, so I'm crossing them off. See how it's easy to just kind of miss numbers. So I'm going to cross this off, cross this off. I'm left with 5, 2, 7. None of those can break down. None of them can put together. So we're just going to put them all, multiply them all together and get square root of 5 and 2 is 10 times 7, 70. Final answer, 24 root 70. If you type that in your calculator, you should get the same answer as the original. And this, you can't break down 70. Even though it kind of looks big, you can't break it down. It's all prime. So therefore, 24 root 70 is your final answer. Anybody get 24 roots of 70? Not bad. Not bad. Okay. Those of you who didn't get 24 roots of 70, hopefully you saw what you might have missed. Okay. Let's see. If you got that one, you're probably pretty good at this. Let's try a harder one. Let's try this. Let me try a fraction one. How about that? Here's an example. Let's see. Square root of 8 over, we'll say 27. There. It's not that hard, but it's a fraction. I'm curious to see if anybody will get the right answer. You all will? Want to bet money on that one? I do certain questions on purpose, so let's see what happens with this one. So, square root of 8 divided by 27. I'm sure you all got the first couple steps. Square root of 8. Square root of 27. Square root of 8 on top is?
2 root 2.
2 root 2. Square root of 27?
3 root 3.
3 root 3. How many people got this answer? Okay, you're wrong.
You have to multiply the root 3 on top of the 11.
Yeah.
So here's a rule that I wanted you to find out this way. If you come up with, this can't simplify anymore, but here's the deal. You can never have a root in the denominator. You probably want to write yourself that note. Okay? You might have heard that before. You can't have a root in the denominator. Never, never, ever, ever will you give me an answer with a root in the denominator. Ever. Okay? Now, because of that, we have to do something to this answer. We have to make it different. Actually, what type of denominator is this right now? What type? What type of number is that? What type of number? Irrational. Irrational. This is an irrational number, which means we have an irrational denominator, which means that's why we call this method something.
Rationalizing.
Yeah, we're about to rationalize the denominator. This is irrational, so what we're going to do is we're going to make it rational. Rationalize the denominator. Know what that means. We're going to make this rational, which means we're going to get rid of the root. How do we get rid of a root when there's a root in the denominator is the question. Multiply it by something. What can we multiply root 3 by to get rid of root 3? By itself, right? Okay, if I multiply it here, so I'm going to write this, I'm going to rewrite this. 2 root 2 over 3 root 3. What you're going to do is you're going to multiply the bottom by root 3. Now that's a common mistake. Everybody wants to write the same exact whole thing down here. You don't need 3 roots of 3 right here. You only need a radical to cancel out this radical. You don't need to write 3 roots of 3. Okay? Only you need a radical to cancel this one. So if I multiply by a radical on the bottom, I need to multiply it on top, right? Why? What are you really multiplying by here?
1.
Really multiplying by 1, right? This is 1. What happens when you multiply something by 1? It keeps the same value, right? But is it going to look the same? No. So let's rewrite the look of it. So 2 times root 2 times root 3 becomes 2 root 6. Now look at the bottom. Be careful with this. People mess this up all the time. What is 3 times root 3 times root 3?
3 times root 9 versus 3 times 3.
Okay. Yeah, this is 3 times, this is root 9, which is 3. So this is 3, and this is 3. 9. Okay? This is your best answer. What did you just do? You made the denominator rational. That's why they call it rationalize. We don't want irrational numbers in the denominator. Why? I actually don't know why, but they don't want them. Okay? So, any questions on rationalizing? Basically multiplying by the same root. It's easy now. It'll get harder later. Alright, let's move on then. These are all, you can do all these, I think. Let's practice rationalizing. That's example 2. Example 2 is all about rationalizing. I just taught you how to do letter A, so let me let you do letter A. Rationalize square root of 5 halves. If I were doing letter A, I would do step 1, square root of 5, square root of 2. I'd split it up using my property. And then I look at this and say, I can't do this, I can't do this, so I should be done. But remember that rule. You can never have a root in the denominator, which means we have to rationalize by multiplying by root 2. Right? Root 2 in the bottom, root 2 in the top, root 2 times root 2, 2. Root 5 times root 2. Root 10. Root 10 divided by 2 is root 5, right?
No.
Nope. Can't cross out 10 and 2. That's not a root down here. Okay, so be careful. Root 10 over 2. Now look at letter B. Have you ever tried things like letter B? Have you ever tried to rationalize things like letter B? If not, here you go. Let's think about letter B for a second. I can't simplify anything. 3, 7, nothing. So the only thing I can do, I can't have this down here. So I need to multiply by something that would get rid of the square root of 2. What would that be? Now, your first thought is probably, oh, Root 2 would work. But think about this for a second. If you multiply root 2 to this whole thing, you would get root 2 times root 2, which is 2. But then you get root 2 times 7, which is 7 roots of 2, which doesn't cancel it. So therefore we have to multiply by something different than root 2. Know what it is? Seven minus root 2. Look at those two things. Have you seen that before?
I mean, special.
Yeah, it's a special pattern. Difference of squares. A plus B, A minus B. What happens when you had A plus B times A minus B? That was A squared minus B squared. But you don't even have to think of it like that. Okay? What happens when you multiply these two together by FOIL? 7, 49. Outside 7 and negative 2, so minus 7 roots of 2. Inside, plus 7 roots of 2. You see what happened? And then positive this, negative this, become, what does that become? Minus 2 whole. Look what happened. Minus 7 plus 7 roots of 2 become 0. So therefore we're left with 49 minus 2, which we could still make that 47. But if you thought about this up here, A squared minus B squared, look, A, which is 7 squared, which is 49, minus B, which is square root of 2, squared, that's 2, gives you 47. Either way you look at it, you can get the same answer. Okay, now we got to do the top. 7 minus root 2 up top. So 3 times 7 minus root 2. 3 times 7, 21. 3 times root 2, 3 roots of 2. No, that's not square root of 6. Okay, there you go. Now 21 minus 3 roots of 2. Can I simplify this to 18 roots of 2? Yes or no? I get people to do that all the time. What is that like? That's like 21 minus 3 times some x, right? Can you simplify this? No, that's the same idea as this. Can't simplify that. Don't try, please. You're done. Over. Game over. Okay? There it is. 21 minus 3 roots of 2 over 47. Final answer. Can't simplify any more than you did right there. Oh, you need to know what this concept is called. What did you actually multiply by? Do you know? You had 7 plus root 2. I'll call this A plus root B. What did you multiply by? You multiplied by A minus root B. You know what these two things are called? These things are called conjugates. Know that word? So if I say multiply by the conjugate, you should know what I mean, okay? So if I said, hey, 3 minus the root of 7. If I said multiply by the conjugate, you would say 3 plus root 7. Okay, you get the idea. Know what the word conjugate means. These two are conjugates of each other. Okay. Any questions here?
So conjugate is only if the sign is different?
Yep. Yep.
And
Everything else the same. Just the sign. Yep. There you go. All right. Let's mix it up a little bit here. Let's do an experiment. We're going to get to this in a moment. Experiment. People are falling asleep here. Got to wake people up. Dropped objects. Write this down. Let's see. Dropped objects. You need to know this formula. H equals negative 16 t squared plus this. Now notice there's two h's here. Anybody know what this one means? H does mean height, but there's a h here and an h here.
That's the change in temperature.
Okay? What's the key word? Yeah. See this little 0 right here? That means anywhere you put that, I think, anywhere that I've known, it's always the initial whatever we're talking about. So h sub 0 is equal to your initial height of what? Of what?
The object drop.
Yeah, the object that you drop. Object. Okay? But what is this h then? If that's the initial height, what is that h? Okay, some people think final height, which is, that's a good thought, you know. The final, some people say final height, but a little bit better, a little bit more specific, it's the height after something. What else is taken into play here? What else is taken into play? Where's that ball? Where's that ball? Annie, got my ball?
Yes. No. I just passed it down.
I could do this to you. Okay? I could say, how long does it take for this to go to here? So, here's the initial height, whatever this is. And here's the height after what?
Release.
Yeah. After so many. What is the other variable here? Time, which is in seconds. So this is the height of the ball after so many seconds. So that, technically that's what h is. The height after how many seconds? Depends, right? Yeah, so we have to say t. So h is the height after t seconds. Okay, so what is t over here? T is time in seconds. What is the height in? I didn't tell you. What do you think height's in?
Feet.
Yep, height is in feet. So make sure height is in feet and time is in seconds. If not, you change it to height or feet in seconds. Okay. Now that you know this formula for dropped objects, make sure you write dropped objects because I'm going to give you another one where we're going to throw it. I'm going to throw as hard as I can right there. Okay. Okay, I'm going to throw it up in the air. What about a volleyball player? You guys play volleyball. The spike, right? Is it going to take the same amount of time for it to start here if I let it drop or if I... Right? Don't hit my coat. Okay? All right. It doesn't take the same amount of time, does it? Because I applied the force. So there's only one more component that we would put in that equation right there. Okay? So, here's my question for you then. Here's my question. How long should the ball take to fall from that height and hit the floor? How long should it take? Well, we measured it ourselves. We said about 0.6. How long should it really take, though? Because we could have been off just by a little bit in our calculations. So how long should it take? Well, we can figure it out based on this right here. Let's figure it out. What do we have to know to figure it out? Okay? So the height. I already measured the roof. The roof is 8.6 feet. The roof is 8.6 feet. So, first thing I would do is I would write, as soon as I said drop an object, the first thing I write is this. H equals negative 16t squared plus h sub 0. What did I just tell you? The initial height was 8.6 feet. Now, here's my whole question. Here's all I have to ask you. If the initial height of the ball was 8.6 feet, how long does it take to hit the floor? What else am I telling you that I'm not telling you?
0. The height.
The other height. Am I telling you time? No, I said how much time. So I'm looking for t. So I have to give you the other h, but I didn't say it. I said how long till it takes to hit the floor, which means it has a final height of 0. So there's the key information. The height when it hits the floor is 0. Equals negative 16t squared. What I want you to do is, I want you to solve this, but actually based on your skills so far, you might not be able to. That's what example number 3 is all about. So, how are we going to solve this one? What way do you normally know how to solve? Factoring, right? Can you factor that?
No.
When you do factoring, there normally is a what that you don't see here. Yeah, ax squared plus bx plus c, right? There's normally a bx. There's no bx here, right? So therefore, we don't want to factor. So here's the little tip for yourself. If there's no bx, you don't want to factor. Okay? So what do you want to do then if you don't want to factor? You're going to get t by itself. Here's the deal. Let's get t by itself. So which means I'm going to subtract 8.6. Do this with me. Subtract 8.6. You get negative 8.6 is equal to negative 16 t squared. Now what? Divide by negative 16. Divide by negative 16. T equals, I'm just going to say the positive of this, 8.6 divided by 16. Oh, not t. Yep, t squared. Now, t squared equals 8.6 divided by 16. T squared, not t. Okay, so how do you get t squared to be t? Yeah. Why do you square root it? Because that's the what?
The square root of t squared is t.
Okay. Those are opposite. If you square something and you square root something, those things are opposite operations. So how do you get rid of a square? You square root it. So if you square root this side, you have to square root this side. So write that down. So you're left with t equals, all you have to do now is use your calculator. Square root 8.6 divided by 16. What should the time have been? What should Dawn have had on her hand, in her, what should it have said? How long should it take? In your calculator, it should be something like 0.73 something. Okay, we'll just round it here. About 0.73 seconds. You said 0.6? Not bad. Not bad. Alright, pretty close. This is exactly what it should have been though. Okay? Here's the deal. You just learned how to use this formula to solve for falling objects. How much time it would take for a falling object. Now I could throw a wrench in it for you, which I like to do. I like to make you think. Where'd my ball go again? There it is. If I asked you this, if I held it to the roof, if I said, how long does it take for it to hit my hand? What do you need to know?
The time it took and the height.
Okay, you need to know the initial height. We'll just say it's 8.6. But then you also need to know this height right here, which is 3 feet. I don't know. Okay, so you would put 3 feet in for the final height, right? You would put 8.6 for the initial, 3 for the final, and then solve for t if you want to do that. You understand? So just ask yourself this. Where's my initial? Where's my final height? Do they tell me the time, or am I solving for time? Okay? That's all you need to know for this problem. Okay? Let's get into example 3. All right. Now that some of you are awake, let's go to example 3.
Is this going to be in a quiz next class?
Yep. Yep. Anything I cover today will be on the next test. All right, example 3. How are we going to solve this equation right here? We're going to factor. No, because there is no bx. Not going to factor. Go ahead. Get x squared, or actually get x by itself. See how far you get.
She verbally doesn't.
Okay, let's check it out. Since we don't factor, let's get x by itself. Minus 5, minus 5. Your x squared equals 36. Shh. Divide by 3. X squared equals 12. Everybody should have got here. X squared equals 12. I'm going to take you off for a second. I'm just going to write a new problem up to the right. You don't have to write it down. X squared equals 9. What's your answer?
3.
I'll write a box. Box blank squared equals 9. What could go in the box? 3. Negative 3. So here's the deal. Anytime you have x squared, there's always 2 answers. Always. Even if it's like this. X minus 2 squared equals 0. What's your answers here? What's your answers?
Minus 3.
What's your answers here?
Oh.
2 and x minus 2 squared is x minus 2, x minus 2. Answers are 2 and 2. There's still 2 answers here, but this is called a double root. But it only write it once, okay? There's actually still 2 answers, but we only write it once, okay? So what I'm saying to you is any x squared function you have, there's always 2 answers. Always. So which people mess up because they only put the positive one instead of the negative one. So be careful. Here we go. How do you solve x squared equals 12? You square root it. Square root it. Square root x squared, you get x. But here's the deal. Here's my little advice to you. Anytime I square root x squared, I always put plus or minus. Anytime you square root x squared, you always account for 2 answers, plus or minus. Okay? Please remember that fact. If you forget that fact, you will lose several points. Now, plus or minus square root of 12, which is really, what?
2, 3.
You better be good at that. Right? If you left at root 12, guess what? Take a point off. Okay? Any questions on this? No questions, huh? All right. Let's solve some more equations now. Make sure you do the plus or minus, please. Don't forget. Okay, next type. It's a little bit different, but it's kind of same in the end. There you go. Write this equation down. 1/5 z plus 3 squared equals 7. We want to solve this equation. Question is, how do we approach something that looks like this? How do we approach something that looks like this? What do you guys think we do first in this type?
Simplify the fraction to the
Okay.
side. And then
Yep.
root it and then
Okay. All right. Stop there. Here's the deal. Here's what people mess up. Like on the test, because there's so many sections, people will say, "Oh, it's a quadratic. Make it equal to 0." So people move the 7 over. Make it equal to 0. You have to know in your own mind. Should I make it equal to 0? Should I not? You have to know what to do, when to do it. Okay? If there's no bx, don't factor. Stuff like that. Don't mix yourself up. So in this case right here, I wouldn't make it equal to 0. Yeah, what Annie said. We have to get rid of 1/5. How? Times it by 5. Times it by 5. Write that step first. If you didn't do so already, write it. So when you multiply by 5, cancels out. Z plus 3 squared equals 35. Here's where people differ on opinions. Where should we go with this? Okay? Some people say that. Other people will say. That kind of is factored already, but. Okay? Foiling it? Okay? Now, here's the deal. So most people see this. Most people see this and they say, "Oh, I should FOIL this, get an answer. That's your like automatic response. But that shouldn't be automatic response when you're solving for x or z or whatever. You want to get rid of the square. How do you get rid of a square? You square root it. So that's the easy way. You could multiply it through, and you're just going to have a lot more work to do. Okay? But the easy way to go, square root it, square root it. What happens when you square root this? You get z plus 3. Those cancel. Square root and the square cancel. You're left with z plus 3 equals root 35. But what? I square rooted z squared. You forgot already? Always, there's always, if it's x squared, z squared, there's always two answers. Know when to do plus or minus. Okay? Please don't forget. Now, we still haven't got z, so we have to minus 3, minus 3. People get confused with this kind of stuff. How do you write something like this?
You have two answers.
Yep, you do have two answers because there's plus and minus. How do you write this? Well, people will say two things. Some people say this plus or minus this, or is it this plus or minus this? It's only one way. You can only go one route here. The plus and minus is with this. You have to keep it that order. So you have to put negative 3 plus or minus root 35. So negative 3 plus or minus root 35. There you go. Final answers. Yes, there's two answers here. Negative 3 plus root 35 is one answer. Negative 3 minus root 35, another answer, which makes it letter, if you see it up here, it's letter C. There are two answers. Now tell me this. What did you find? What is this right here?
Z.
Okay, true. Z.
Should be 0.
Solutions. True.
Oh yeah, it's the.
So it's a negative.
Here's where you have to put everything you learned together. Here's what I want you to do. Let's check something in the calculator. Type in the calculator the original function, but you can't really. Why can't you type this exactly the way you see it? Because it equals 7. What should you make it equal? 0. Once you make it equal to 0, where are you going to type it? Y equals button. Hit the Y equals button, and then hit 1/5 z plus 3 squared and minus 7 because we subtracted 7 on both sides. Okay? Put this in your Y equals button. Hit the graph key for me. You should see the whole, well, you should see the parabola here. Okay? I taught you guys how to do what with this? Find zeros. I need you to remember how to find zeros in the calculator. I did this last class, and I swear half of them forgot how to find zeros. I told you how to find a left boundary and a right boundary. If you don't know how to do that, you need to get with your peers, have them teach you again, or come to me, and I will teach you. Set a left-hand boundary and a right-hand boundary. Okay? So you're going to see in your calculator something like this. Okay? I want you to find these zeros real quick. Should take you a couple minutes. Okay? If you're going to go for this 0 right here, you set up a left-hand boundary. So it could be here. Set up a right-hand boundary. Could be here. It doesn't matter exactly where it is. Press enter, enter, enter after you do that. And then it'll pop up right here. It'll tell you what that is. Make the other one. Make a left boundary here somewhere. Make a right boundary here somewhere. And then hit enter after on guess, and it'll bring you right here. Find out what those two things are, please. You can round for a moment 2 decimal places. Tell me what those are. Please know how to do this. It will help you on the test. It will help you check things at least. Okay, give me one, gentlemen. Negative 8.91 is the left-hand one. Okay, good. What is the right-hand one? Positive 2.91, something like that. 2.92. Okay. Either one, yeah. If you were being technical, yeah, put the 2 there. Now here's what I want you to do. In your calculator, I want you to type in these 2 answers right here. Type in -3 plus root 35. Enter. Get your decimal. Type in -3 minus root 35. Enter. Get a decimal. Look at those. Notice something. One of them, did you get 2.91 or 2.92? One of the two. Did you get negative 8.91? What did you find?
Zeros, x-intercepts.
Yeah, you found the zeros of this up here. You found the x-intercepts of this up here. So let me give you a problem that I would give on the test here. So here we go. Let's say -1/3 times x minus 2 minus 7 equals 5. I want you to solve this problem. Can't get much more complicated than that unless I threw more decimals or fractions at you. So if you can solve that without a problem, yeah, you should be pretty good. You definitely have to do a specific order. So technically what you're supposed to do, get the parentheses by themselves, which means you have to do what first?
Times, add 3 or times? I mean, add 7 times 36.
Add 7. Have to add 7 first. If you multiplied 3 first, don't do it. Have to add 7 first. If you multiply by 3, this is a binomial here. You'd have to actually multiply 3 times this, which cancels out. But then you'd have to multiply 3 times 7. You can't do that. Okay? That's why we want to get the parentheses by themselves. Okay? So we got a plus 7 first. Plus 7. So we get 1/3. X minus, I'm glad I guess I made this one up. Okay? Because some of you are getting the wrong answer. Equals 12. Now what can we do? Now we times it by 3. And then we get cancel out here. This is 36. X minus 2 squared equals 36. Now we can square root. Square root. X minus 2 is equal to what? Plus or minus 6. Now look what happens here. Plus 2 on the bottom. Plus 2 here. So here's what we get. 2 plus or minus 6. I hope you don't leave this like this. You can do this. 2 plus 6.
8.
8. 2 minus 6.
-4.
-4. Here's your 2 answers. Everybody pay attention to that. Okay?
You want us to put in the bracket thing?
That'd be nice. Yes. Any questions on this?